Hi everyone, today we'll be doing the topic of arrays in Java. So until now we have learned how to do variable declarations, how to print stuff on the screen, how to read the information from the user. And today we'll be doing a little bit more advanced version of a data structure as compared to variables, which is arrays. Let's say we have a problem, okay? Our problem is this. We want to ask the user how many days temperature would you like to enter. Then we'll basically ask the user, for example, the user has said 7, okay? So we'll ask the user 7 different temperatures, and we need to store those temperatures in our program. Then we'll have to calculate the average temperature. Then we'll have to print how many days were above the average, okay? In order to do this, normally if we only had variables, we had to declare 7 different variables. But we have one more problem. We don't know how many days the user is going to request. So based on this, we don't know how many variables we have to declare. So therefore, we have to use arrays. So for each input value, we have to calculate the average, and we have to calculate how many days were above the average. And if we simply have 7 different variables, coding this is not very efficient and is not very easy. Therefore, we're going to go for arrays. But before we start with the arrays, I'm going to start with the terminology first. So in the array, we have the elements. These are the contents of our array. Then we have the indexes. These are the locations that we use to access the array elements, okay? So 2 things, indexes and the values and the elements, okay? Value and the elements is the same thing, by the way. So, for example, the arrays are consecutive blocks of memory, okay? And in order to access these consecutive blocks, we need the indexes. As an example, the first thing we're going to see is how to declare an array. The first thing you have to specify is the type of your array. What is your data type? Is this an integer? Is this a double? Is this a floating point number? The first thing, you define your type. Then right after the type, you have to have the square brackets. This specifies that this thing that you are going to declare is an array. Then you have the name of the array. Okay. Right after this, we have new, type, the length. Also, you have to specify the length of your array. In the example, you see that we are declaring a numbers array, and this numbers array is going to have 10 different values. Okay, and right after you do your initialization, for integer type, your default value is 0. For double type, your default value is 0.0. For boolean, it's a false. For strings, it's a null. Okay, if in case you don't know what a null is, this means empty or no object in case of objects. Okay, so when you are declaring an array, the length can be any kind of expression that evaluates to an integer value. So in this example over here, you see x is equal to 2 times 3 plus 1, which is a 7. And we have int data new int. 7 mod 5 is 2, and 2 plus 2 is 4, which means that we are declaring a data array which is going to have 4 different elements. So the first thing we do is declaration of the array. The second thing we need to do is assign values to our array. Okay. In this example over here, for example, we have number 0 is 27. This means that the zeroed index of this array is going to be 27. Then we have number 3 is equal to -6, which means that the third index of this array is going to be a -6. Okay, so then we have system out print line number 0. This means that go to the array, retrieve the information that is in the zeroed index, then print it on the screen. Then we check if numbers is less than a 0, we print elements 3 is negative. Is this the case? Yes. If you go look at the array given in below, we know that index 3 is equal to -6, which is the case. Then we print element 3 is negative. So in this example, you see how to declare a double array. So we have double results, new double 5. This means that declare a double array that is going to contain 5 bits of information. Then we have results 2 is equal to 3.4, which means that the second index is going to contain 3.4, then fourth index is going to contain minus 0.5, and the rest of the elements are equal to 0.0. As I said before, when you do the array declaration, in case you don't assign anything to this array, by default the array will contain 0 or 0.0 if this is a double, 0 if it is an integer, and for all the other data types we have the corresponding 0 equivalent values. For the case of Boolean, we have all falses right after the declaration. Then we change, for example, test3 to true, which means that all the indexes except index 3 is equal to true. 3. There is one thing we have to be careful about when we are working with the array. You have to be careful about your bounds. As in, you declare an array with 10 elements. Okay, so this means that your indexing will start from 0 until 9. This is also important. When you declare an array with 10 elements, your indexing will always start from 0, not 1. Okay, so this means that the indexes you can access along with this array is ranging between 0 to 9. And in case you try to access a negative index, which is data minus 1, you get an index out of bounds exception, because we don't have such an element. Okay, if you try to access data 10, this is also index out of bounds exception, which means that this element does not exist in our array. Okay, so this is you have to be checking this index out of bound exception by yourself. This is your responsibility when you are doing your own coding. So when you want to access the array elements, as in use them or print them on the screen, straight away you write the array name followed by the index. Okay, if you have a look at this example, first we declare a numbers array with 8 elements. Then we initialize some of the elements of this array, as in numbers 1 will be equal to 3, numbers 4 will be equal to 99, number 6 will be equal to 2, and the rest of the elements will be equal to 0. Then when we have int x is equal to numbers 1, x is equal to 3. That's one thing. Then we say numbers 3 is equal to 42. This means that the third index, since x is equal to 3, the third index of our array will be equal to 42. Okay? Then we have numbers. Number 6 is equal to 11. So number 6 inside the first square bracket specifies our index. Therefore, number 6 is equal to 2. Therefore, numbers 2 will be equal to 11. So when you are doing the indexing, you can use any kind of mathematical expression that will evaluate to an integer. When you are working with the arrays, you definitely have to use some kind of a loop structure, because the arrays that we have seen so far, we have 8 elements, we have 10 elements, that's one thing. But in case you have an array with 100 elements, 1,000,000 elements, how are you going to process this array? When you are doing this, you definitely have to work with loops. This can be any kind of loop, as in for loop, while loop, do while loop. And in this slide, you can see an example where we are printing the contents of the array using a for loop. See, our loop control variable is equal to I, and we start from 0. And our for loop will iterate from 0 until 7 with increments of 1. Okay? This means that in the first iteration, when I is equal to 0, we are going to print number 0, okay? The value in the first element, the value of the first element. Then we print numbers 1, numbers 2, numbers 3, numbers 4, and so on, okay? So if you want to print the contents of your array, or if you somehow want to process the contents of your array, you definitely have to go for the loops. Also, you can do assignments to your array using the loop structures. And in this example, you see I is equal to 0, and when I is less than 8, we have increments of 1. See, in the very first iteration, when I is equal to 0, follow this code along with the contents of this array. Therefore, when I is equal to 0, number 0 will be equal to 2 times 0, 0. Then when I is equal to 1, the contents of the first index will be equal to 2. When I is equal to 2, the contents of first index is equal to 4, and so on. Therefore, what we're doing over here is we are assigning values to our array, and when we are doing this, we are assigning double the index to this array. When you are working with the arrays, you don't have to hard code the length of array to your for loop. You can use dot length. You know how arrays are actually objects, and when you want to extract the length of this array, straight away you write the name of the array, dot length, and this will simply return the length of your array. So if you have a 10 element array, numbers dot length will return a 10. Okay, so this is a much more safer way to work with arrays. Instead of hard coding the length, go for dot length. Okay, so over here you see I will start from 0, and when I is less than numbers dot length, every time we have increments of 1, and we are printing the contents of the array on the screen. So what happens is, be careful about this length, because remember, if you have a 10 element array, numbers dot length will return a 10, but your indexing, as it is starting from 0, will start from 0 until 9, not 10. So you have to be careful about this. And when you are working with numeric data types, straight away you go for dot length. But when you are working with strings, you go for dot length parentheses. Okay, this is important. In case you don't have dot length parentheses with the strings, you'll have a syntax error. So, going back to our original problem that is presented in the first slide, this is the kind of program that we want to have. First, we would like to ask how many days temperatures would you like to enter. So this can change. This is just an example. In this case, the user has set 7, but the user can say a 10, a 20, a 100. It depends. And based on this given days value, we're going to ask for 7 different temperatures from the user. We are going to store these values into an array. Then next thing we have to do is find the average value of these temperatures. Then the next thing, the last thing, we're going to print how many days were above the average. Okay, as I said before, if the user will request for 10 elements, then we're going to ask 10 different temperatures. Then we have to define an array with 10 elements. So this is our solution over here for the given problem. See, at the very beginning, we define our console object, as we are going to request the user to give us the days, number of days, and the temperature. So the first thing we do, we define the console. Then we print a message on the screen saying that how many days temperatures would you like to enter. At this point, the user has to provide a value, how many days. In order to read this value, we have to define a variable called days. Then days is equal to console.nextInt. At this point, the user will type 7 and press enter, and this value will be stored in days variable. Okay, this was our first job. Now it is done. The next thing, we have to define an array with days, numbers of elements. So if days is equal to 7, we have to define an array with 7 elements. Okay, so this is what is done in int temps is equal to new int days. Okay, so we define an array with given number of days. Then we define a sum variable. Remember how we used to calculate the cumulative sum of given values? This is what we're going to do over here. So this is the variable that is going to store the cumulative sum of all temperatures. Okay, then we have a for loop starting from 0 until days, and in each iteration we print a message on the screen saying that day 1 1's high temperature, day 2's high temperature. And this is going to iterate until number of days, which we assume that it was equal to 7. So this for loop will iterate 7 times, and in each iteration we ask for corresponding day's temperature. Then the given temperature will be stored in the corresponding array element. So the first temperature will be stored in temp 0. The second temperature will be stored in temps 1, and so on. Also, we are going to calculate the cumulative sum of all given temperatures, and when for loop is done, in the temps array we're going to have 7 days worth of temperature data, as well as the cumulative sum of all these temperatures. See, in the system out print day, I plus 1 is given for the sake of appearance. As I is starting from 0, we wouldn't like our program to say please enter day 0's high temperature, but we would like our program to say day 1's temperature. That's why we have I plus 1. Okay, we simply shifted the indexing to actual day numbers. Then right after the for loop, we calculate the average. How are we going to do this? We are going to divide the cumulative sum with the given number of days. Remember, if both our operands are integers, which is the case for sum and days, both sum and days are integers, we end up with an integer division. With integer division, we don't get the actual result, but the part after the point is dismissed, as in 5 divided 2 would be equal to 2. Therefore, we have to do casting. And right in front of sum, we have the double. We are casting sum, we are basically taking sum as a double. And since we do this, we do actual division. In the case of casting, you can do casting in front of the sum. You can do casting in front of days, or you can do casting in both, in front of both variables. Okay, any case would be okay, but you have to do casting in either of the operands for sure. Okay, at this point in average variable, we have the average temperature. So what we have done so far, we have written the temperature data, we have calculated the average. Now we have to find out how many days were above the average. For this case, we have defined a count variable, which is initially equal to a 0. And what we have to do is we have to go through contents of the array one by one and check how many elements of the array are above the average value. And every time we encounter a value that is above the average, we increment count by 1. Okay, so this is what is done in the next for loop. We go through each element of the array one by one. Every time we see something that is above the average, we increment the count. Right after this piece of code, right after the second for loop, we have our results. Now what we have to do is print our results on the screen. So we say average temperature is %1F average. Why do we have %1F? It's again for the sake of appearance. This means that print only one digit after the dot, and then we print the number of days, which is stored in count variable, were above the average. So until now we have seen how to do array initialization element by element. Now this is the case we are doing a quick initialization. So in this case we have the same structure. We have to specify the type of our array, followed by the brackets and the name of the array, and inside the curly brackets straight away we write down the values. This means that our array declaration is done implicitly. You don't have to specify the number of elements. It is initialized based on the given number of values, which in this case we have 7 different values, which means that we are declaring an array with 7 elements, and straight away each value is stored in corresponding index. So array traversal. Array traversal basically means you going through the array, elements of the array one by one, and doing some processing on them or checking them. It depends on your task. For example, we have a piece of code over here. We define an array A, and inside this array A we have 7 different values again. See, we have a for loop starting from 0 until a dot length minus 1. A dot length is equal to 7, as we have 7 elements in this array, and 7 minus 1 is 6. Therefore, I will start from 0 until 5 with increments of 1. And every time we are checking if a value is greater than its neighbor, we basically double the neighboring value. So, if you have a look at this example over here, the very first value of a is equal to 1, and the next value is equal to 7. So in the piece of code, in the very first iteration, when I is equal to 0, we compare. Is a0 greater than a1? Is this the case? No, we skip this step. Okay? When I is equal to 1, we check. Is a1 greater than a2? Since this is the case, we have 7 greater than 5. What we're doing is we are doubling the value of 5. Now, the second index of this array is modified. Now its value is 10. Okay? Next iteration, we are comparing 10 with 6. Okay, so in the given array below, it is the final version, so don't be confused. So now we are comparing 10 with 6. Since 10 is greater than 6, we double 6 again. Then next iteration, we are checking, doubling the 6, the third index becomes a 12. Okay, in the next iteration, we compare 12 with 8. Since 12 with 4. Since 12 is greater than 4, we again double index 4, it becomes an 8. Next iteration, we compare 8 with 14. Since 8 is less than 14, we skip this step. Again, next iteration, we compare 14 with 11. 14 is greater than 11, which means that we are going to double 11. 11 becomes a 22. So in the given array below, you can see the final version of our array. And why do we have a dot length minus 1 in the for loop? Because until now, when we were traversing the array, we were starting from I is equal to 0 until I is less than a dot length. Since every time we are checking the array element and its neighboring value, if we basically have I is less than a dot length, at this point, the very last value we'll be checking will be index 6. And in the code, in the if statement, we'll be comparing index 6 with index 7, which doesn't exist. Therefore, that's why we have a dot length minus 1. We only go until index 5, and this is our very last iteration of the for loop, and we compare index 5 with index 6, then do our processing and complete the for loop. So you have to be careful, as I said before, instead of having a dot length minus 1, if you have a dot length, this means that you'll have index out of bound exception. So once you create an array, you cannot resize it. That's not possible. So in the given example over here, we create an array with 4 elements. You cannot go ahead and update a dot length saying that now my array is going to have 10 different elements. That's not possible. Another thing, you cannot do array comparison with simple logical expressions, as in I have 2 arrays A1 and A2. I cannot compare if A1 is equal to A2, or I cannot do A1 dot equals A2. That's not possible. There are some methods doing this job for us. I'll show them in a bit. And also, you cannot print out an array straight ahead. Okay, there's also a method doing this job for us, but you cannot apply simple logical expressions, as well as you cannot print an array straight away system out print line statement. So in Java, we have arrays class, okay, and this arrays class is defined in java.util library. In case you want to use this arrays class, you have to import java.util library at the very beginning of your code. And we have some useful methods. Some of these are binary search method. Binary search method is a searching method where it takes an array as an input as well as a search value. And if this value exists in your array, it will return a true. And if it doesn't exist in your array, it will return a false. We have another method called copyof. This copyof method will take an array as an input as well as the length of an array as an input, and it will create a copy of a given array with given number of lengths. Okay, so let's say I have an array and it has 5 elements. If I call copy of array with 3, it will create a copy of this array with first 3 elements of the array. Then we have the equals method. This will simply compare two of your arrays. The inputs are 2 array inputs, and it will return a true if these 2 arrays are equal. It will return a false if they are not equal. Then we have a fill method, and the inputs to the fill method are the array and the value. In case I provide an array and the value that I provide is equal to 10, this means that take this array and fill all elements of this array with value 10. Okay. Then we have the sort method. The sort method will simply sort your array in increasing order. It would be very useful in some cases, and I'll show you an example of this in a bit. And last thing we have is the toString method. ToString, if when you call the toString method, it will simply print the contents of your array on the screen. You don't have to do this explicitly using a for loop. In case you prefer, you can also do that. But if you are simply going to print the contents of the array on the screen, go for the toString method, because it is some kind of a shortcut, much more efficient. So when you want to call these methods, as these methods are static methods, you have to have arrays.method name with the given parameters. So this is an example of how to call toString method. I have an e-array, then I have done a simple processing with the e-array where the value of e1 is updated as e3 plus e4, and basically e1 becomes a 14. Then we have e is arrays.toString e. This means that print on the screen e is the contents of array. And as I said before, if you are going to go for arrays methods, the methods that are defined in the arrays class, you have to import java.util package, otherwise you can't use them. So this is a simple modification to our primary problem. In this problem, we have taken the temperatures, we have found the average temperature value, then we have said that 4 days are above the average. Now I would like you to do one more thing. The first thing, print all the given temperatures on the screen. Also, print 2 coldest days and 2 hottest days on the screen. How are we going to achieve this task? So this is the solution to this problem. The very first part is the same as before, so it is not written down over there. So if you have a look at the last paragraph of this code, the last bit of this code, we have system out print line, temperatures is arrays.toString temps. This means that print all the temperatures on the screen straight away. Then what we do is we sort the temperatures array. This means that all the temperatures will be sorted in increasing order. So if I want to retrieve 2 coldest days, I'm going to check first 2 elements of the array. And if I want to print the 2 hottest days, which are the highest values in the array, I'm going to check last 2 elements of this array. Therefore, we have 2 coldest days is equal to temps 0 and temps 1, which is the first 2 elements of this array. And if I want to print 2 hottest days, temps.length minus 1 and temps.length minus 2. This will simply retrieve last 2 elements of this array. So the next thing we're going to see is how to pass arrays as parameters to the methods. The first thing that I would like to show you is how to swap values first. This is not relevant to passing values to the arrays, but we're going to use this. That's why I'm showing this piece of code to you. So if I want to swap 2 values, I have 2 variables, A is equal to 7, B is equal to 35. If you straight away go ahead and say A is equal to B, A becomes a 35, and B is equal to A now A is equal to 35, now B is also equal to 35. This means that in the very first statement, I have overwritten the value of A, which means that it disappeared. Both A and B are now equal to 35, and I don't know the old value of A now. Therefore, in order to do this job, I need a temporary variable. Okay, so I define a temporary variable and I say int temp is equal to A. I store the value of A somewhere. Okay, then I say now A is equal to B. which means that A is equal to 35. Then I say B is equal to temp, with, and you know that temp stored the old value of A. This means that now B is equal to a 7. Therefore, I have swapped the values of A and B using this temporary variable. This is important, otherwise you won't be able to swap these two values. So, I would like to write a piece of code. Okay, so I'm going step by step. This is also irrelevant to passing arrays as parameters, but this is a part of the code that you're going to see in a bit. So I would like to write a piece of code that will reverse the contents of an array. In order to do this, this is our logic. Take up the first value and take up the last value and swap them. Then go ahead to the first index and the index right before the last one and swap them. Go ahead, increase your indexes, swap them. Now we have reversed our array. See, in order to achieve this task, we went halfway through the array and we have swapped each element with the corresponding neighbor, okay? In the symmetric neighbor, okay? So I'll show you straight away the correct solution. Have a look at the last part of this slide, because the first part doesn't do the job right. In the last part of the slide, see, we have a for loop starting from 0 until numbers.length divided by 2, which means that we are going to go to halfway through our array. In case in the first part of the array we have a problem, in the first part of the code we have a problem. If we start from 0, and if we go through all the elements of the array, we basically reverse the array, then we put it to its original position back. That's why it is flopped. That's why we have to go to halfway through the array, okay? Then what we're doing is we are swapping index 0 with the last numbers.length minus 1 minus I, which is basically assuming that I have an array with 5 elements. We would be swapping index 0 with index 4. Next iteration, we would be swapping index 1 with index 3. Okay, then in the second index, we are basically swapping second index with itself. It doesn't make any difference. So this way we are reversing the array. Okay, so we would like to write a piece of code, a method, okay, that takes an array as an input. So this is how you declare a method that takes an array as an input. So we have public static, this is fixed. The type specify what is the return type of your method. What kind of data are you going to return? This could be a void, this could be a void, this could be a double, this could be an integer. Then we have the method name, and our input is type brackets name. This means that I'm going to take up an array as an input to this array. Therefore, the only difference between regular variables and the arrays is this. You have to specify that you are passing an array as an input, and this is specified by the brackets. So we have int brackets number says that I'm going to receive an array as an input, and when you want to process this array within your code, this means that you can also retrieve the length of this array. As you see in this piece of code, what we're doing is we are calculating the cumulative sum of the contents of the array. Then we calculate the average of this sum value, the sum of the elements, then we return the average. The bottom line is this, as compared to regular variables, we know how to pass regular variables to the arrays. In this case, we have to specify the fact that we are passing an array, and this is specified with int brackets numbers, which means that I'm going to return and I'm going to provide an array as an input to the method. When you are calling the method, if the return type is void, then straight away you can call reverse numbers. If your return type is not a void, this means that you have to assign the return value to a variable, or you have to print it on the screen. Okay, so this will be it for today. I'll be posting the rest of this lecture in lecture management system. You can follow the rest of the slide from there. So I'll see you later.